Hello guys. So today I want to give a novel proof for the standard series. Okay, so the first one is you guys already know that 1 over n squared will be pi squared over 6. And if you go on YouTube, then many people will use the Fourier series or sine x equals to this one, and they use the Taylor expansion. And then write it as x minus x squared, and they can write it as 1 minus x squared pi squared, and do the expansion and match the coefficient, so they can get this one. But today I want to give a novel proof. Basically, so I want to use integral to solve this. Okay, so now we can start doing novel proof. Okay, so novel proof. Basically, if you know the period in mathematics, then you can Google this and find this proof. So the standard operation is like so this one is 1 plus 2 square, 1 over 3 square, 1 over 4 square. Okay, so this is zeta 2. Okay, so I can times this 1 minus 1 over 4 2. So it becomes, now this 1 over 4 will cancel this term, right? So basically it becomes like this. So only the odd number survives. So how about this one, right? I can write as 1 over dx, 1 over dy, because it's 1 times 1, right? And then I can write as 1 over x squared dx, 0, 1 y squared dy. And this is 1 over 1/3, and keep going. Okay, so basically you can see that this is 0, 1, 1 plus x y squared, x first y first, dx dy. So basically you write it as a geometry series. So 1 over x y squared dx dy. Right, so amazing thing is if we can do this integral. Okay, so let me write the integral carefully. It's this one, right? So if I can do this, then I can get the answer, right? So now we do the integration. Okay, so basically it's very non-trivial that you can see how I can do this integration. So basically I can let x equals to sine u divided by cosine b, and y equals to sine b equals to cosine u. So basically you know that since x is 0 from 0 to 1, right? Y is from 0 to 1. So basically when x equals to 1, then that makes sine equals to sine should equals to pi over 2, right? And the cosine should be 0. As v should be 0, right? So it means that suppose this is xy, so our xy is a cube, here is a square, and the uv it should be like, when this is pi over 2, then x is 1, right? So sine pi over 2 is 1, and the cosine 0 is cosine 0 is 1, and another point is d. Right, so you can check that it's basically a triangle. Right? So finally, we need to calculate the Jacobian of or the Jacobian of this matrix. Right. So let's do it. Right. So okay, let me change this color. This color is not good. So partial x partial u is equal to cosine u cosine v, right? And partial x partial v is equal to sine u sine v and cosine square v, and partial y partial u is equal to sine v cosine u squared. So basically there should be minus sign, but cosine u the derivative of cosine u is minus sine u, so the minus can cancel. and partial v, partial y, partial v is cosine u. So basically, the integral becomes the triangle and du dv and 1 over xy squared. So let me write xy side, right, and the Jacobian. So basically, this is determinant of this object, right? Right. If you do it carefully, you will see that this term multiplication will be cosine u cosine b cosine u cosine b minus sine u square sine v square. Oh, so I miss. So the x times y should be sine u sine v cosine u cosine v. Right. So I miss this part. So it should be sine. Right. So this is v and du dv. Right. So basically, you see this term is 1, and this term is the same as this term, so it cancels. So finally, it's amazing that this is just du times dv, and this area. So this area is just triangle, right? So the area is 1/2 of pi over 2 squared, so it's pi squared 8. And basically, we have 1 minus 1 over zeta 2 is equal to pi over 8. So it's pi over 6. Okay, so this is very amazing that you guys can do this. So basically, so another video I will show how to do the zeta 4. Basically, I will show that. So the next video, I will show zeta 4 equals to pi to the 4th over 90 without using Taylor expansion and the Fourier series. So I will use some novel way to show this. Okay, so thanks for you guys watching. If you like this video, please subscribe and please press the subscribe button below this channel. Thanks.